So the definition of domain is that all values of independent variable for which dependent variable exists are in domain. What this basically means is to find if a particular value of x is in domain, we have to check that for a value of x, does y exist? Here's what this means in practice. Let's say that x equals 5. So if we put 5 in this function, we get y equals 1 over 0. 1 over 0 is undefined, or you could say approaching infinity, or infinity. So if we put a value of x and the answer for y is undefined, then this particular value of x is not included in the domain. So x equals 5 is not in the domain. However, if we check for x, we get the value 2. So x equals 6 is in the domain. So the domain of this function overall is domain is all real numbers except 5. So if we put any value of x, for example, if we put x equals 1, we're going to get negative 3 or negative 4, which is 3 over 4. So we're getting a real number. Similarly, if we put 2 or any other value other than 5, we're going to get a fraction or a whole number. So it's only for x equals 5 that the value is undefined. For example, another function, if you could take an example, is y equals 1 by x. If I put x equals 0, then y would be 1 by 0 and it would not be in domain. But for any other value of x, y, for any other value of x is in domain for y. So that is what domain is. We're basically just checking that for a value of x, does y exist or not. Now, on the other hand, range is a difference between highest and lowest possible values of a function. So, basically to find range, what we're going to do is we're going to plug values of x which are in domain and find out what is the maximum and minimum answers produced. What we're going to do is let's take one of our functions that we took as example, y equals 1 of x. First, let's find the domain of this function. So we know that when x equals 0, then y equals, so it is not defined, hence x equals 0 is not in domain. Now if we try some other values like x equals 1, then y equals 1 by 1, which is also 1. If we try x equals minus 1, then y equals minus 1. If we try x equals 2, then y equals 1 by 2, and so on. And further we could use 3, x equals 3, x equals 4, x equals 5, negative 3, negative 4, and it would not be of the form 1 by 0, hence it would be in domain. So the domain for this function we know. So now we have found the domain to be all real numbers except 0. So if we put all real numbers in the equation, we are getting answers like 1, negative 1, 1 by 2. Similarly, if we put x equals 3, if we put x equals 3, we would get x equals 4 and we would get, and so on. And if we do the same with negative 3 and negative 4, we get something like, so I mean you must have noticed a trend in these values, and which is something like if we see 1 by 2, it is actually 0.5, or and negative 1 and negative 1.1 by 3 is 0.333. This is negative 0.25. This is 0.25. This is 0.333. So what you're seeing is basically, if I had to show it in the number line, this is 1 -1 and 0. So if you see what for whatever value of x we put except 0, what we find is if we put x equals 1, then the value of y is 1. If we put x equals 2, then the value of y is 1.5, 1 by 2, which is 0.5. And if we put it as 1 by 3, x, if we put the value of x equals 3, then it's going to be somewhere over here, which is 0.33. This is going to be 0.25. So it's basically like the function is approaching 0, and from the negative direction it's doing the same. But for no value of x which is in domain, the value is equals to 0, because if we put x equals 0, it is undefined. So y equals 0 does not exist. So we could say that the range of this function is between 1 and -1, excluding 0, because for any value of x which is in domain, y is not equal to 0. So that is domain and range.